Hello, everyone, and welcome to the Math Bender. I'm Adnan Zedi, and this session is going to be another extension of permutations and combination, traditional mathematics, as well as S1 in A levels. In this session, we'll discuss some few cases where the question's direction is more or less the same. So, if we try to comprehend to those cases, so we could be easily able to understand how the question. So let's start. So before starting off with, we can discuss the example. So eight friends. So let me write out of them four are men and four are women. They are going to a theater together and they all have tickets for adjacent seats. So let's construct the first thing, try to construct a rough map what it is. Now these are the eight seats and in how many ways they can be seated together. So the question here is without any restriction, they haven't imposed any. So in the first one, anyone can be seated anywhere. So there are eight people, irrespective of the fact whoever it is, but there are eight people that can be catered here. For every eight possible ways that can one at a time fill this one slot, there are seven left because one person is seated on the first. Seven out of those seven, then there are six times five, 4, 3 times 2 times 1. And hence, if we remember from our previous session, if you haven't watched that, you may watch that session before coming on to this one. So, if we see this one, this is as same as 8 factorial. So, there are 8 factorial ways, which is equals to 40320. So, there are these ways they can be seated without any restriction. So let's say if we have a scenario where all men have to be together. So if I have those 8 seats, so there are 4 men and there are women. Not necessarily. Now the question is that if we try to construct, we can see that it can be also like this. So men can be here as well, yet together. And there are many ways. So let's try to see or make a block out of it. So let's make a block here and call it a compartment as capital M. So now I can say that capital M, women, women, and women, and women. So they all can shuffle because the whole block of 4 men can be here, can be here, can be here, and can be here, yet they are together. So if there are 4, so 4 is going to be, so there are, what you do is, you just take down as 1, 2, 3, 4, 5. 5 factorial times. Now, since men in the block yet can shuffle within themselves, making a different permutation, so you can say that they are 4 factorial times 5 factorial. So let's have an example of how we can take a look at this one. So a shelf holds 7 different books. Out of those, 4 are cookery books and 3 are the history ones. So number of ways can be arranged if there is no restriction. So what you could do is when there is no restriction, so which means that the first one, A, is going to be 7 factorial. So the books can be arranged in any way, but let's say 4 cookery books have to be kept together. So there are 7 books in all, and if I keep these cookbooks together for a moment here, and I make a block of this, so inside they will be shuffling within themselves, which makes it 4 factorial, and then making a whole big block of cookbooks and arranging them with other history books is again 1, 2, 3, 4, 4 factorial. So this is going to be 4 factorial times 4 factorial. So what you could take from here is that when the question states that they are together, so you make a block of it and try to shuffle them within themselves like this 4 factorial, and then shuffle the whole block of four books or four whichever it is. Try to shuffle these books with the other history books. Now let's say if we have men and women alternate, which means so out of that, let's keep men here first. Now in this way, women will be seated in these spots. Now, if I try to see, there are 4 men, 4 possible ways each man can be seated in this way. If one man gets to be seated here, then there are 3 men gets to be seated rest. Then if 2 men are there, then already 2 left, and then 1 here. Same goes if I write for the women. So there are 4 women here. There are 3 women left here. Then there are every 2 women left here, and then 1. Now if you see, if you try to take all the blue ones, this is as same as 4 factorial times if you take the red ones, this is as well 4 factorial. So rather than getting into the depth of it, you can straight away write 4 factorials times 4 factorials. But in this scenario, this isn't it, because they are even number, both of them are in exactly same number. So if I can also place these women here, and same goes for men can be in the center. Hence, men can shuffle within these spots. And there are 4 men which are being shuffled. So 4 factorial times women can be shuffled within these spots, and hence it is also 4 factorial. So there is a total of when men at first and women at first, so it's a 4 factorials times 4 factorials, and we have to add with this one as well. So you can eventually write it as 4 factorials times 4 factorials times 2. Let's look at another one where men is going to be at each end. So let's look at this. Now, as I can see, there has to be 1 man here and 1 man here. And we have 4 men in the question. So, one at a time, but there are 4 possible ways 1 man can come here. If 1 man comes here, there are 3 possible ways men can be catered there. Now, rest in the center, there is no restriction. Whoever can be in whatever order. So how many people are left? So if 2 people are already in the end, then it's going to be 6 people left, which makes it 6 factorial. So the final answer is going to be 4 times 6 factorial times 3, which makes it equals to 8640. Now let's look at an example question. So the first one, you have to arrange the word orange, and without any restriction for part A, if there is no restriction, it's going to be what? 1, 2, 3, 4, 5, 6. So it's going to be 6 factorial. For part B, the number of arrangements that has to begin with O. Now, so it has to begin with O, which means the first letter has to be O, and it is fixed now. You cannot shuffle it. It has to be O already. So this, in this spot, there can be rest of 5 letters that can come here, then 4 letters that come here, 3, then 2 letters, and then 1. Hence, it is going to be 5 factorial. The last one, having O at one end and E at the other. Now, it did not mention which end are they talking about. So let's try to roughly make a map of this. So O at one end and E at the other, but it can also be E at one end and O the other end. If they had mentioned that O starting with O and ending with E, we would have had a clear idea, then we would have taken this one only. But it, as it mentions, that it has to be any of the ends. So what we can do here, that O and E are fixed, rest of the remaining 4 letters can be shuffling within themselves. And if E at first and O at the end, it could be 4 factorial. So hence it's going to be 4 factorials times 2, which gives you a total of 48. All right, so let's look at an example, at another example where we could see all the cases merged together. So for part A, there are 3 girls and there are 2 boys. So there are 5 people in all, and they are to be seated in a row. So let's make that arrangement. 1, 2, 3, 4, and there are 5 people to be seated in that row. The girls and the boys sit alternately. So in this scenario, you could see that this is the only possible way a girl can come here, here, and here, because there are less number of boys than girls. So the girls can shuffle within these 3 spots. So it's going to be 3 factorial. And boys can shuffle within these 2 spots. So it's going to be 2 factorial. So since 3 factorial is 6, 6 times 2 is going to be 12. There are 12 ways you can arrange it in this order. A girl sits at each end of the row, so which makes it a girl to be here, another girl to be at the other end, and hence we have 3 people left. It could be arranged in any order. So for this, it has to be 3 ways because there are 3 girls, one at a time if one girl comes here. So there are 3 possible ways this girl can come at this end, times with, if one of the girl comes in this first slot, then there are 2 girls left to fill that last one, times with 2. And then in the center, 1 girl and 2 boys, they can arrange in any order, there is no restriction there, so hence making it 3 factorial. So 3 times 2 is 6, and 3 factorial is 3 times 2 again 6, which makes it 36 number 36 ways. For part C, always remember to make this rough diagram so that you can at least construct your question from here. So the girls sit together and the boys sit together. Now this is again all men together, so I'll approach it the way I've already explained. So let's keep this girls, 3 girls in one nutshell and 2 boys in one block because they have to be together and the girls have to be together. So making a whole for girls and for boys. So I'll keep this block as G. So as I could see, if I make this one, it's going to be 2 factorial because they both are shuffling. The boys, the the group of boys can be at first and the girls on the other end, hence. So moving on, I can say that if this is 2 factorial, now girls within themselves can shuffle times with 3 factorial times boys within themselves can as well shuffle times with 2 factorial. So 6 times 4, there's going to be 24 ways in all. So this is it for today. We'll discuss more on how what selection is and how to cater to those type of questions in our next session. Until then, take care. Bye.